Okay, so in this example, we're gonna learn how to graph a rational function using the domain, the vertical asymptote, the intercepts, and the horizontal asymptote. So let's start with the first example. In this example, we're being given this function. The first thing we have to do to easily identify everything is to factorize our function. So we're going to factorize both numerator and denominator. So for our first example, our factorization results in x plus 3 times x minus 1, and the factorization below it's minus 4 and plus 2. Once we have that, the first step is to identify the domain of our function. By now, we know the domain is found by finding the invalid values of the denominator. So from our denominator, we have these factors. Each factor is going to give us an invalid value. And those invalid values are the values we remove from the domain. So the domain is all real numbers except 4 and minus 2. The vertical asymptotes are exactly those values we removed. So the vertical asymptotes are exactly these two equations. Notice that either vertical or horizontal asymptotes, they are equations, so make sure you write them as an equation. Once we have the vertical asymptotes, I'm gonna immediately plug them into my graph. Remember, the vertical asymptotes are never touched. That means that your graph will never do something like this, or like this, or like this, or like this. They can never be touched by your graph. Okay. Next thing we're gonna find is the X and Y intercept. For the x-intercept, the only thing you have to do is to find the zeros from the numerator. So here you have your numerator. So for the x-intercept, we're going to find zeros. We're going to find the zeros of the denominator, and the factors in the numerator are x plus 3 and x minus 1, giving us the value for x equals minus 3 and x equals 1. So the x-intercepts are x equals minus 3 and x equals 1. So that means my function is going to cross the x-axis here and here. Notice that the graph is only going to touch the x-axis in those points. That's why they are called x-intercepts. Now, the y-intercept is found by evaluating the function in 0. So if I evaluate the function in 0, this is going to give me 0 plus 3 times 0 minus 1 over 0 minus 4, 0 plus 2, resulting in the expression minus 3 minus 8. That is 3/8 positive. That means the y-intercept is going to be around here. The last thing we have to find is the horizontal asymptote. For this, we have to find the degree of the polynomial in the numerator and the denominator. Remember, the degree of a polynomial is the highest exponent. So for example, for the numerator, the polynomial in the numerator, its degree is 2. And for the polynomial of the denominator, the degree is 2 again. So, because the degree of the numerator and the degree of the denominator are the same, the horizontal asymptote is going to be obtained by dividing the leading coefficients of both numerator numerator and denominator. What does that mean? Remember, leading coefficient is a coefficient that accompanies the important term. In this case, because these are quadratic polynomials, these ones are the main coefficient, and thus these are the leading terms, and thus the number accompanying these polynomials, these terms, are the leading coefficient. So that means that the horizontal asymptote is found by dividing those coefficients. The coefficient of the numerator is 1. The coefficient of the denominator is 1. So 1 over 1 results in 1. So the equation y equals 1 is the resulting horizontal asymptote. Now, the only thing we have left is to graph this expression. To do that, there's a couple of things we have to do. The easiest thing we can do is to evaluate on each side of each vertical asymptote. So notice that the vertical asymptotes are dividing our plane in 3 different places: here, here, and here. So in each one of those places, we're going to have a piece of a graph. I recommend you to start graphing in the piece that has, or the pieces that have already values that we have found. For example, the intercepts. That's why I'm going to start graphing in the middle part. So to graph the part of the graph on the middle part, we're going to evaluate on a number that is close to the vertical asymptote on this side and on this side. So because I'm graphing in the middle, the limit for my graph is on the left side is the asymptote x equals -2, and on the right side is the asymptote x equals 4. So a number close to -2 on this side on this part of the plane is -1. So I'm going to evaluate my function in -1. The function evaluated in -1 is 2 times -2 over -2 times 4. Sorry. -5 times 1. So this is gonna be -4 over -5, that is 4/5, meaning my function is gonna pass through this point. Now let's evaluate in a number that's close to the asymptote to the right. In this case, my asymptote is in x equals 4, so I'm going to evaluate in x equals 3. So the function evaluated in 3 is 6 times 5 over 2 times 3 plus 5, 5. Giving us 6/2, that is 3. I did something wrong. Is 3 minus 4 minus 1 and 3 plus 2, 5. So this is -6. So in 3 my function is -6. So my function is gonna pass through this point, through this point, and through this point. Notice that because my function is evaluated here, my function has no other way but to cross all the way here. Now, would my function go upwards or downwards? If my function could go up all of a sudden, that would mean my function would cross the x-axis again. And remember, we can only cross the axis in the intercepts. So that means we have no other way but to go down. So my function is going to continue to -infinity. On this part, the same logic applies. Because the values we obtain is positive, this means my function is going to go into positive infinity. It cannot go into negative infinity because that would mean that I would be crossing the x-axis again, and we can only cross it on the x-intercepts. So that's it for the middle part of my graph. Now, the second place where... Okay. For the second part is we're going to start working with the other place where we have a valid and we already have a point. In this case is this place. So again, I'm going to evaluate in a number that is close to the vertical asymptote. As you can see, an integer value that is close to the asymptote is -3. And notice that there we have an x-intercept. So we can go either this way or this way. The first thing we have to remember is that the horizontal asymptotes are only touched in the middle part of my graph. That means that my function cannot cross this asymptote, and moreover, we have to remember that asymptotes have this pulling behavior, meaning that when the function gets close to it, the asymptote is going to pull the graph and make the graph go closer and closer to the asymptote without ever touching it. That means that because here's a value and here's an asymptote, my function is going to get close to the asymptote without ever really touching it. So that means my function could never behave like this, because my curves are always gonna go close to my asymptotes. So because my function has this behavior around these asymptotes, and this is an x-intercept, that means that my function is gonna cross here, and the only way for the function to go is downwards, because if this is an x-intercept, it means my function crosses the x-axis, and it cannot go all the way back again, because that would mean you would be crossing or touching the x-axis again, and that is impossible. Meaning that for this piece, my graph will look like this. And for the last part is this one. Notice we don't have any important point here, so what we have to do is just to evaluate. Always evaluate in values that are close to the vertical asymptotes. In this case, my vertical asymptote is 4. So I'm going to evaluate in a number close to it. You can either choose 4.1, 4.01, but to make things easier, I'm going to evaluate in 5. So f of 5 is 8 times 4 over 1 over 7. So this is 32/7, that is almost 5. Remember, this symbol means almost or approx. So my function for the coordinate value of 5 is 32/7. That means that point is around here. So for a number close to my vertical asymptote, the value was positive, meaning that my function is going to go to positive infinity. And because the horizontal asymptote can only be crossed in the middle parts of my graphs, this means my function is going to go like this without ever touching the horizontal asymptote. That's it for example number 1.